Good evening, everyone. Let's look at a comprehensive redox reaction question. I am Mr. Rish. Thank you for joining me. We have to demonstrate a redox reaction between hydrochloric acid and aluminum solid. Also, if 0.01 milliliter drop of 6 molar HCl is placed on 0.03 millimeter thickness of aluminum block, determine the diameter of the hole that is generated in that aluminum as that drop of hydrochloric acid penetrates and perforates that aluminum block. The density of aluminum is 2.7 grams centimeter cube. The first part is not too hard. The second question is a little tricky. We have 0.01 milliliter drop of 6 molar HCl which will be placed on 0.03 millimeter thickness of aluminum block. We have to determine the diameter of the hole that's generated. You know, if you're looking at a block in the three-dimensional perspective, it's looking like that. If you're gonna put a drop over here, it's gonna basically make a hole in here, and that hole will be the shape of a cylinder. So we're looking here at a volume of cylinder pi r squared h, and we have to keep that in mind. The hole which will be generated through this block will be the hole in terms of a volume of a cylinder, pi r squared h. That formula will come in, but let's do this in a piece by piece manner. The question is not too hard. Look right here, HCl, which is aqueous, plus aluminum solid will generate AlCl3, which will be an aqueous, and then we'll have H2 gas. The reaction will be in this direction because the gas will be liberated and it'll push the reaction towards that side. You have to balance this. You're gonna look here 3, and you have 1 here, you have 2 here. If you put a 6 over here, you put a 2 here, 2 here, and a 3 here, everything is balanced. You can look at everything here with regards to oxidation states. This will always be +1, -1. This here is 0. These are individually -1. Aluminum will be +3 because it's counteracting 3 -1s from chlorine. This will be 0. Oxidation state of chlorine doesn't change, but aluminum changes. It is oxidized. Hydrogen changes. It is reduced. You're looking here at this. Aluminum is converted into Al3 plus 3E minus. Hydrogen, you're looking here at this H plus to give you H2. Don't worry about these coefficients. We don't need them anymore. You're looking here at this, and then 2 electrons. You're balancing this individual half reaction. You have to balance now the total half reactions. Multiply this by 2, multiply this by 3. When you multiply this by 2 and 3, the 6 electrons will cancel out. You'll end up seeing 2 aluminum solid plus 6H plus. This is aqueous, will give you 2 aluminum, these aqueous ions, and then you'll have plus 3 hydrogen, and you'll see this. Now we have a balanced reaction. This balanced reaction should be good. We have 6 positives here, 6 positives here, 2 aluminums, 6 hydrogens. We're good. I'll transfer this reaction here on the top because now the part A has been done. We just have to worry about part B. Now we will do part B, and for this, you have to use a calculator. We have 0.01 milliliters. With regards to molarity and moles, you always want to look at liters. Molarity is equal to moles over volume. Moles is equal to molarity times volume, and we have 6 molar times 0.01 ml, but you have to do 0.01 divided by 1000 converted into liters. This will give you your moles of HCl. You'll determine the moles this way. You'll have 6 times 0.01 divided by 1000. We have 6 times 10 to the minus 5. 6 times 10 to the minus 5 moles HCl. But how can we determine H plus? Because this is what we're looking at. HCl dissociates completely to these because it has a very high equilibrium constant. It dissociates completely. Water is the moles or molarity of this is equal to the moles or molarity of that. So this right here is equal to 6 times 10 to the minus 5 moles H plus. Now bring everything here with regards to aluminum. You have times 2 moles of aluminum cation per 6 moles of hydrogen. And what will you get? You'll do 6 exponent 5 minus times 2 divided by 6. You'll get 2 times 10 to the minus 5 moles aluminum. We have here a density factor, which means we should convert this into grams. Multiply this by your molecular weight, which is grams per mole of aluminum. And what will we get? You'll have 2 exponent 5 minus times 27, the molar weight, to give you your grams. Remember, moles is equal to mass over molar mass. Mass is equal to moles times molecular weight. I'm doing that. I'm getting 5.4 times 10 to the minus 4 grams. I have 5.4 times 10 to the minus 4 grams aluminum. You know density is always equal to mass over volume, or volume is equal to mass over density. I want to get the volume of aluminum because I want to get the volume into this formula, because I know that hydrochloric acid is going to go through that aluminum foil and it'll perforate a hole, and it's a three-dimensional foil with a certain thickness will generate a cylinder in terms of an imprint of a cylinder, and that's exactly what we're looking at. We'll divide this by that 2.7. What will we get? Divide this by 2.7. I'll get 2 times 10 to the minus 4. We'll get 2 times 10 to the minus 4 centimeters cube. Remember, this is grams per centimeters cube. You see this, so we'll have this. The volume is equal to 2 times 10 to the minus 4 centimeters cube. You don't need much of this else anymore. All of this can be removed because now we're looking at this volume formula. I'm removing all of this because it has served its purpose. We have volume, which is equal to 2 times 10 to the minus 4 centimeters cube. It's a unit of volume, is equal to pi r squared h. We have a height. If you're looking at a thickness, the thickness is equal to height. Look at that little piece of aluminum. It has a certain three-dimensional nature to it. The thickness is your height, and we'll bring in the height. But this is in millimeters. Here we're seeing centimeters. 0.03 millimeters is 0.003 centimeters, and that's what we have. And now we brought in the height component. All you have to do is solve for this r, and then we have to determine the diameter, and the diameter is twice the radius. So whatever is your radius, you multiply it by 2. We'll do this entire calculation here on the calculator. We have 2 exponent 4 minus. We'll divide this by your height, which is 0.003. We'll divide this by the pi factor divided by pi, and then we'll square root it. I'm getting 0.1456. 0.1456 centimeters. Therefore, diameter must be equal to 2 of this. We'll multiply this by 2 because 2 radius is equal to 1 diameter. Multiplied by 2, we get 0.2913. 0.2913 centimeters. That will be the diameter of the hole that's generated in that block of cylinder as the hydrochloric acid drop dissolves it and penetrates it and pushes right through into the other side. And the question has been solved. This answer should be right. This equation here should be right, and everything is done. It brings us to the end of this video. Thank you for watching.